In this example, we are going to determine the exact values of the 6 trigonometric ratios for the angle pi over 6. So when we look at the exact values of the 6 trigonometric ratios, we are looking for sine, cos, tan, as well as each of their reciprocals, which would be cosecant, secant, and cotan. So those are the 6 trigonometric ratios that we are going to solve for. So I like to use sketches to determine these, as I prefer a more visual approach. It's nice to see things in front of me to help me figure out what my answers are going to be. So I always draw it out on a quick sketch. So I might give you a plane like this, or you might have to sketch your own. But this is always where we'd start. You draw it out. This would be my 2 pi, also 0, right? And pi over 2, pi, and 3 pi over 2. So this is where we're going to start. And I'm going to solve this question using 3 steps. Step 1 is always going to be to draw my angle on the plane here. So I'm going to draw pi over 6 on the plane. And this is the plane here. So pi over 6, okay, that also in degrees would be about 30 degrees. And again, these are the things that you're going to have to memorize. Okay, so I'm going to draw pi over 6 on the plane here. And since it is 30 degrees, it would be closer like that. Okay, so that is step 1. Step 2 is where we are going to make a triangle. We're going to take the end, drop it down to the x-axis. I'm going to make a triangle with the x-axis, always the x-axis, never the y, it's always the x-axis, and label the special triangle that it makes. So I'm going to make a triangle. I'm going to take that end right down to the x-axis here, making a triangle. And now we're going to label the triangle that this makes. So when we drew this at pi over 6, right? So now I have to take a look and think, okay, is this going to be a 1, 1, root 2 triangle? No, doesn't look like it, because if this is 30 degrees, or pi over 6, this is going to be a 1, 2, root 3 triangle. Well, my 2 always goes on the hypotenuse. But then I have to figure out which side is the 1 and which side is the root 3. Well, the way I like to remember is the smallest side is opposite the smallest angle. So if I think about it as 30 degrees, this is the smallest angle. So opposite the smallest angle will be the smallest size. If we're purely looking at it in radians, we have pi over 6, right? Sometimes it's confusing between pi over 6 and pi over 3, which one might be the bigger. But you can think about it. If you're cutting a pi into 6 pieces, you get a smaller slice. Smaller slice means a smaller angle. Or if you have a pie, like an actual pie, you cut it into 3 pieces, it's a pretty big slice, which means it would be the bigger angle. So that's a little trick I can remember to help me here. So if that's 1, that's 2, that makes this down here root 3. Step 3. Now we are going to write out the ratios, ratio or ratios, depending on what they've asked for. I'm going to write out the ratios asked for in the question. Well, they asked for all 6. So we're going to write out all 6 ratios for pi over 6. That means we're going to write out, I'm going to find sine of pi over 6. We're going to figure out what that is. Then we'll do cos of pi over 6. Then we'll do tan pi over 6. Then we're also going to have to figure out the reciprocal trig functions. That's where we're going to do cosecant of pi over 6, secant of pi over 6, and cotan of pi over 6. Now, don't forget we've memorized what sine, cos, and tan are, right? Sine is going to be y over r. Cos is my x component, which is so it's going to be x over r. And tan is my slope. It's y over x. We have cosecant. It's just a reciprocal of sine. So it's just these guys flipped. So cosecant will be r over y. Secant is r over x. And cotan is x over y. Well, let's take a look and figure out which is our x, our y, and our r. Well, the r is always this guy right here. Right? That is my radius of this circle. This piece down here is my horizontal piece. So this, root 3, is would have been on the x axis, right here on the horizontal, which makes this my vertical component in line with my y-axis. So that is the value of y. So now I can go through and just fill in my numbers. So sine of pi over 6 is going to be y, which is 1, over my r, which is 2. Okay. Actually, here, let me put those colors in there so you can see where those numbers are coming from. My 1 over 2. Cos is going to be my x, which is root 3, over my r, which again is 2. Okay, and finally, for my tan, what am I going to have? I'm going to have my y, which is 1, over my x, which is root 3. Now, you guys will remember from dealing with radicals that we don't like root symbols on the bottom. Okay, so we need to clean this up. Make it a little bit easier for us if we have to go ahead and use this later on. So I want to get this root sign, or this radical, out of the denominator. So I'm going to multiply this by essentially 1, so it holds the integrity of the original statement, but I'm going to multiply it by root 3 over root 3. Because when I do that, if I multiply the tops, multiply my bottoms, root 3 times root 3 is just a positive 3. So let's see what this will look like. So this will actually turn into, we multiply the tops, 1 times root 3 is root 3 over, now root 3 times root 3, those cancel, leaving us just with this. And you can actually test that on your calculator. You can do 1 divided by root 3 and get a number, and compare it to when you do this, root 3 divided by 3, and I bet you will get the same number on your calculator. Next up, we are going to find the reciprocal of sine, which is cosecant. But the nice thing is, we already have the ratios. All we have to do is flip them. So for cosecant, instead of 2 over 1, it's going to be 2 over 1. instead of root 3 over 2, it's actually going to be 2 over root 3. But we're not allowed to have a radical on the bottom, are we? So we have to use the same idea that we used here, multiply it by essentially 1 to get rid of that radical on the bottom. So when I do that, I multiply the tops, multiply the bottoms, leaving me with 2 root 3 over root 3 times root 3 is just 3. Okay. And finally, for my last one here, now I'm actually going to look back to this instead of this, because if I flip this guy, it's actually going to give me root 3 over 1. So I don't have to worry about doing all this, because if I flip this guy, it would have been 3 over root 3, and then I've got a radical in the bottom again, and I don't need to multiply it by this, because I can just look to my original, because that is just equal to root 3. That is how we find all 6 trig ratios for the angle pi over 6.